Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve questions from revision questions chapter of Oxford General Navigation book. So far we have practiced many questions. We will continue that and keep practicing more and more new questions so as to gain confidence and skill to pass all the DGC exams. So let's start with today's question number 1, which will be question number 172. Simple question. The Ramline distance between points A and B is what? Okay, so point A is 60° north, 2° 30 minutes east. Point B is 60° north, 7° 30 minutes west. So, right. These are the two coordinates. One is 60° north, degree 30 minutes east, and the second is 60° north, 7° 30 minutes west. To find Ramline distance between them. Now, Ramline distance is equal to b long in minutes into cos lat. B long is nothing but difference between two longitudes. Over here, it is 7° 30 minutes west plus 2° 30 minutes east. Different hemispheres add. So 7° 30 minutes plus 2° 30 minutes is equal to 10 degrees. So 10 degree, convert that into minutes, 60 into cos 60. So Ramline distance will be equal to 600 cos 60 is half, which is 300 nautical miles. So correct answer is option A, 300 miles. 173. Task, temperature, flight level. Calculate the Mach number. The Mach number equals to true airspeed upon local speed of sound. True airspeed is given to us. Local speed of sound is 39.17. Temperature in kelvins. Okay. So now we outside air temperature in kelvins. Now they have told us that outside air temperature is ISA temperature plus 10 degrees Celsius, warmer than ISA temperature. So first calculate ISA temperature at given altitude, 41,000 feet. So ISA temperature equals to 15 degrees Celsius at mean sea level minus 2, which is your lapse rate, into 41,000. So 2 into 41. 15 minus 82. 15 minus 82 is minus 67. So ISA temperature is minus 67 degrees Celsius at 41,000 feet. Okay. But now one more thing. Now this we have calculated according to our lapse rate. But one more important fact is that above 36,090 feet, ISA temperature is constant at minus 56.5 degrees Celsius. Right? So you will have to select minus 56.5 degrees Celsius as your ISA temperature at 41,000 feet, not minus 67. Okay, so remember that. So outside air temperature is therefore minus 56.5 plus 10, which is equal to minus 46.5 degree Celsius. Now minus 46.5 degrees Celsius is nothing but how many kelvins? 226 is equal to 226 kelvins, right? So substitute here. Now true airspeed is how much? 485 divided by 39.17 square root of 226. So 485 divided by 39.17 into root of 226 is 15 into 2. So 39.17 into 15 is 587.5. So 485 divided by 587 is 0.82. 0.82. Okay, so your mock number is 0.87. So the final answer in the calculator is 0.826. So it should be 0.825. Option Bravo. Okay, 0.825. Next, question 174. Fuel flow per hour is 22 US gallons. Total fuel on board is 83 imperial gallons. What is the endurance? Endurance is the time for which your fuel is going to be available for your flight. Okay, total flight time. Okay, so let's say there is, for example, a fuel tank has 100 kilogram fuel, and fuel consumption rate is 10 kg per hour. That means endurance. In this case, endurance meaning the time for which the time, the total time this fuel is going to be available to you is going to be 10 hours. 10 kg per hour, so 100 kilogram fuel will be available for next 10 hours. Similarly, in this question, we have to find endurance. Okay, but look at the units. Fuel flow unit is given US gallons in US gallons, fuel consumption rate, and fuel on board is in imperial gallons. So convert imperial gallons into US gallon. So 83 imperial, so 83 UK gallon. Now convert this into US gallons, which is 99.68. 99.68. 83 imperial gallon is equal to 99.68 US gallons. Now, fuel consumption rate is 22 US gallon per hour. Okay, total fuel 99.68 US gallons, approximately 100. Endurance will be equal to endurance will be equal to total fuel on board divided by fuel consumption rate. So 99.68 divided by 22 is 4.5. That means endurance is 4 hours 31 minutes. So option Bravo is the closest option. Next, 175. Position A is there, position B, position C is also there. What are respectively distances A to B and A to C? So 59 north, 20 west, and Bravo is 60 north, 21 west. Okay, so now you have to first find distance AC. Distance AC is nothing but your great circle distance, difference in latitude into 60. So it is equal to difference between these two latitude is 1 degree into 60 is 60 nautical miles. Next, distance AB is your line distance, B long in minutes into cos lat. B long, 20 west and 21 west is 1 degree. Convert that into minutes, 60 into cos of 60. So 60 into cos 60 is half. So that is equal to 30 nautical miles. So A to B is 30. AB is 30 and AC is 60. Okay, so 30 and 60 is the answer. Bravo. Okay, pay attention to the this sequence. First A to B and then A to C. Don't select option A. Option A is A to C first and then A to B. So pay attention to that. 176. Flight level is there, Mach number is there, temperature is there. What is true airspeed and what is local speed of sound? Right? So local speed of sound is equal to 39.17 outside temperature in Kelvin. Now what is the outside temperature here? Minus 55 degrees Celsius. Right? It is minus 55. The minus 55 degrees Celsius in Kelvin will be equal to 218 Kelvin. Substitute the values 39.17 square root of 218. The square root of 218 is 14.76, approximately 15. So 39.17 square root of 15 is equal to 152 knots. 152 knots. Okay, this is how you find local speed of sound. Now TAS. Mach number is TAS divided by local speed of sound. So TAS will be equal to Mach number into local speed of sound. So Mach number is zero point 0.8. Local speed of sound is 152. So 152 into zero point 0.8 is 121. This square root of 218 is 15. So this should go, and so it should be 39.17 into 15. 39.17 into 15 is 587.55. So my fault. And this is 0. 0.8 into 587 is 470. So true airspeed is 470. So 461, 461, 490, 237. So Charlie is gone. Delta is gone. Local speed of sound is 587. So local speed of sound is 587. Closest is 576. So option B should be the correct option. Okay, it satisfies both conditions. Both are answers. 177. How many nautical miles are traveled in 1 minute 45 seconds and speed? So distance is equal to speed into time. Speed is 135 knots. Time is 1 minute 35, 1 minute 45 seconds. So 135 into 1 minute 45 seconds is 3.9. Okay, 3.9375. So 3.94 approximately. So option B is the correct option. 78 simple. You A to B is 90. You are 60 miles from A. So I'll take one. A to B distance is 90 total. You are 60 miles from A. You are 60 miles from A and you are 4 miles to the left of track. What correction do you need to make in order to arrive directly at B? So you will have to use track error and closing angle method. Okay, 4 miles to the left. So your diagram is like this: A, B, C. Okay, this is your diagram. Fine. Let's find out track error angle. This is your track error angle. Now track error angle is distance of track, which is 4. Distance gone is 60 into 60. So track error angle is 4 degree. Next, if this is 4 degree, this will also be equal to 4 degree, which is your corresponding angle. Now let's find closing angle. Closing angle will be found in this triangle. So closing angle equals to distance of track upon distance gone into 60, which is equal to 8 degrees. Now if this is 8, this will also be equal to 8 because alternate angles are equal. So now the total angular change that you will have to make is equal to 4 plus 8, that is 12 degree. 12 degree right. Okay. So this is how you need to find this answer. So what correction do you need to make? So you have to make a correction of 12 degree to your right hand side in order to arrive directly at point B. Next, a great circle crosses the equator at longitude 30 degree west. Okay, longitude 30 degree west. The direction of the great circle at equator is 035. An aircraft following this great circle will reach its highest latitude at what position? An equator. So let's draw that. This is your Earth. Okay, there is an equator over here. There is a great circle. Now, one coordinate of great circle is 30 degree west. So, the coordinate where it intersects the equator is 30 degree west. Now, if this is 30 degree west, that longitude should be how much? The total should be 180. So, 180 minus 30 is 150. So, this should be 150 east in the eastern hemisphere. Next thing they say, the direction of the great circle at equator is 035. Okay, the direction of the great circle is 035. 035. Now remember, this is the northern vortex, this is the southern vortex. Okay, the longitude of northern vortex, longitude of southern vortex will be 90 degree different from these two values. So if you are calculating northern vortex will be 150 minus 90, which is 60 degree, 60 degree east. Southern vortex will be 30 plus 90, which is 120 west. So now look at the options. We have 120 west and 60 east in all the four options. Now we will find latitude. Okay, latitude. Now latitude, to find latitude of northern vortex, this latitude will be equal to whatever the direction of your great circle at equator. Okay, it is direction it's given is 035. So to find latitude, you will have to subtract 35 from 90. You get 55 degree. So the latitude will be 55 degree north, 55 degree south. So the correct answer will be 55 degree north, 60 east, not 55 degrees south, 60. In here, it should have been 120 west. Okay, therefore Bravo is wrong and Delta is the correct option. I have solved similar question from Oxford General Navigation Chapter 1 and uploaded it to my YouTube. So watch that video as well. Next, question 180. Heading is 29er. Variation is 90 west. Chart convergence is 55 west. What is magnetic heading? So this is how you do this all the sums from this video lecture. I hope you have understood them. If you have any doubts, questions, let me know. Do watch my next lecture in which I will be solving the next questions from this chapter. See you there.